Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Which factory is more efficient? One where the production line never stops, or one where every worker has the authority to stop it? Surprisingly, Toyota chose the second. When a worker detects an abnormality, they can call for assistance and, if necessary, stop production before the problem moves forward. Toyota understood that producing hundreds of defective components is far more expensive than stopping for a few minutes and correcting the cause. This simple idea represents the heart of lean manufacturing: expose problems, eliminate waste, and continuously improve the system. After World War II, Toyota faced conditions completely different from those of large American automobile manufacturers. Companies such as Ford could produce enormous batches of a few vehicle models. Toyota had limited money, limited space, and a domestic market that required several models in relatively small quantities. Copying the American mass production system would have created excessive inventory and tied up capital Toyota did not possess. Toyota therefore had to design a production system that could manufacture different products, in smaller quantities, with high quality and minimal waste. The Toyota production system developed over several decades. Sakichi Toyota created automatic looms capable of stopping when a thread broke. This prevented the machine from continuing to produce defective fabric and established the principle later called Jidoka. His son, Kiichiro Toyota, promoted the idea of supplying each production process with exactly what it needed, exactly when it was needed. Taichi Ono later combined these principles with standardized work, continuous flow, pull production, and relentless problem-solving to create the operating system now known as TPS. Lean manufacturing developed from studying and adapting this system beyond Toyota. The Toyota production system is often illustrated as a house because every part depends on the others. The roof represents the desired results: high quality, low cost, short lead time, safety, and satisfied customers. The first pillar is just in time, making only what is required, when it is required and in the required quantity. The second pillar is Jidoka, detecting an abnormality and preventing defects from moving to the next process. The house stands on stable processes, standardized work, leveled production, and continuous improvement. Copying one lean tool without building this complete structure rarely produces sustainable results. Lean production begins with customer demand. Takt time is the rate at which a completed product must be produced to satisfy that demand. Suppose a factory has 420 available production minutes in a shift and customers require 210 units. Dividing the available time by demand gives a takt time of 2 minutes. This means the production system needs to complete one unit approximately every 2 minutes. Takt time is not the same as cycle time. Takt time comes from customer demand, while cycle time is the actual time taken by a process. Comparing them helps engineers identify bottlenecks, excess capacity, and poor workload distribution. In a traditional batch system, each department tries to maximize its own output. Parts are produced whether the next process needs them or not. This creates excessive work in progress, consumes floor space, and hides defects for days or even weeks. Just-in-time connects production more closely to actual demand. Smaller quantities move through the factory at shorter intervals. Lower inventory also makes problems more visible. If a machine is unreliable, a supplier is late, or a process is unbalanced, the disturbance appears quickly. In lean manufacturing, inventory is not automatically considered security. Excess inventory can behave like water hiding dangerous rocks beneath the surface. One-piece flow means moving one product, or a very small quantity, through consecutive processes without unnecessary waiting. Imagine that a cutting process produces 20 parts before sending them for drilling. If the first part has the wrong dimension, the problem may not be discovered until all 20 parts have been produced. With one-piece flow, the first part moves directly to drilling and inspection. The error is detected much earlier. Flow shortens lead time, reduces work in progress, and improves feedback between operations. However, it requires reliable equipment, balanced workloads, consistent quality, and quick response to abnormalities. Toyota developed the pull system after observing how supermarkets replenish products. A supermarket does not normally send random quantities to the customer. The customer removes what is needed, and the store replenishes what has been consumed. Lean production applies the same logic. A downstream process withdraws parts from an upstream process only when required. The upstream process then replenishes the consumed quantity. This is fundamentally different from pushing products forward according to a schedule, regardless of whether the next operation needs them. Pull production helps control inventory and directly attacks overproduction. The waste Toyota considered especially damaging because it creates many other forms of waste. Kanban is the signaling mechanism commonly used to control a pull system. The word Kanban can be translated as signboard or visual card. It tells the upstream process what item is required, how much is required, and where it must be delivered. A Kanban may be a physical card, an empty container, a marked space, or an electronic signal. Kanban does not automatically make a factory lean. If demand is unstable, quality is poor, or machines constantly break down, the Kanban system will reveal those weaknesses. Its purpose is to regulate flow and make shortages, delays, and abnormal conditions immediately visible. The second pillar of TPS is Jidoka, sometimes described as automation with a human touch. A machine should not continue producing defects while an operator watches helplessly. It should detect an abnormal condition and stop automatically. Human operators should also be able to signal a problem and request immediate support through an Kanban system. The goal is not to punish the worker who reveals the problem. The goal is to prevent the defect from moving downstream and to restore the process under controlled conditions. Jidoka converts quality from a final inspection activity into a responsibility built into every production step. The second pillar of TPS is Jidoka, sometimes described as automation with a human touch. A machine should not continue producing defects while an operator watches helplessly. It should detect an abnormal condition and stop automatically. Human operators should also be able to signal a problem and request immediate support through an Kanban system. The goal is not to punish the worker who reveals the problem. The goal is to prevent the defect from moving downstream and to restore the process under controlled conditions. Jidoka converts quality from a final inspection activity into a responsibility built into every production step. Heijunka means production leveling. It smooths production volume and product mix over a defined period. Instead of producing a large batch of product A, followed by product B and then product C, the factory produces smaller quantities in a repeating sequence. Leveling reduces sudden changes in labor, equipment, and material requirements. It also improves responsiveness when customer demand includes several product variants. But small production batches require fast changeovers. This is why techniques such as SMED, single-minute exchange of die, are important in lean systems. The objective is not a perfectly flat market. It is a production system capable of responding without constant disruption. Lean manufacturing is often described only as waste elimination, but Toyota focuses on three connected problems: Muda, Mura, and Muri. Muda is non-value-adding activity. Mura is unevenness in demand or workload. Muri is overburden placed on workers or equipment. These conditions reinforce each other. An uneven production schedule can overload one department and leave another waiting. Overloaded equipment may fail, producing defects, delays, and additional waste. A lean system must therefore improve the entire flow, not simply force every machine and every employee to work faster. The common Tim Woods acronym helps employees recognize 8 forms of waste. Transportation is unnecessary movement of materials. Inventory is material waiting instead of flowing. Motion is unnecessary movement by people. Waiting occurs when people, machines, or materials remain idle. Overproduction means producing too early or in excessive quantities. Overprocessing means doing more work than the customer requires. Defects create inspection, repair, scrap, and delay. The 8th waste, underutilized skills, was added in many later lean frameworks. It occurs when organizations fail to use the knowledge, creativity, and problem-solving ability of their employees. Toyota's original classification emphasized 7 production wastes, but employee involvement remains fundamental to TPS. Kaizen means continuous improvement. Instead of waiting only for large automation projects, employees regularly identify small changes that improve safety, quality, delivery, or cost. A common improvement method is the Plan-Do-Check-Act cycle. First, define the problem and plan a countermeasure. Test the change on a controlled scale. Check whether the expected result occurred. If successful, standardize the new method. If not, learn from the result and begin the next cycle. Kaizen is powerful because thousands of small verified improvements can transform the performance of an entire organization. Lean problem solving asks people to investigate the process instead of blaming the operator. The 5 whys method repeatedly asks why a problem occurred until the team reaches an actionable root cause. In this example, replacing the seized bearing would restart the machine, but it would not prevent another failure. The deeper cause was contamination entering the lubrication system during maintenance. The appropriate countermeasure may include sealed lubrication connections, revised maintenance standards, and improved inspection. 5 is not a compulsory number. The principle is to continue investigating until the organization understands why the system allowed the problem to happen. Lean problem solving asks people to investigate the process instead of blaming the operator. The 5 whys method repeatedly asks why a problem occurred until the team reaches an actionable root cause. In this example, replacing the seized bearing would restart the machine, but it would not prevent another failure. The deeper cause was contamination entering the lubrication system during maintenance. The appropriate countermeasure may include sealed lubrication connections, revised maintenance standards, and improved inspection. 5 is not a compulsory number. The principle is to continue investigating until the organization understands why the system allowed the problem to happen. Many lean transformations fail because companies copy visible tools while ignoring the thinking behind them. Installing Kanban boards, painting floor markings, or conducting a 5S event will not create a lean organization by itself. Lean also loses employee support when every improvement is associated with job losses. People will naturally hide improvement opportunities if solving a problem threatens their employment. Sustainable lean manufacturing requires leadership commitment, respect for people, process stability, and a willingness to expose uncomfortable problems. The objective is to develop stronger processes and stronger problem solvers, not simply to make fewer people work harder. A company beginning its lean journey should avoid trying to transform every department at once. Start with one product family and observe the actual work at the place where value is created, the practice Toyota calls going to the Gemba. Map material and information flow, identify the major delays and stabilize equipment and quality. Then establish standardized work, improve process flow, and introduce pull replenishment where appropriate. Track safety, quality, delivery, and cost through daily visual management. Test changes on a manageable scale, learn from them, and expand only after the new system becomes stable. Lean transformation is a learning journey, not a one-time project. So why does Toyota allow production to stop? Because the temporary stop exposes a weakness that can be corrected before it becomes a much larger loss. The Toyota production system combines just-in-time, Jidoka, standardized work, leveled production, pull systems, and continuous improvement. But its greatest strength is not any individual tool. It is the discipline of making problems visible and developing people who can solve them. Lean manufacturing does not mean working faster or keeping every machine continuously busy. It means creating a stable flow that delivers exactly what the customer needs, while using fewer resources and learning from every abnormality. That is the real power of the Toyota production system.